Dear students, today I want to discuss some subjective problems for class 10 students. Topic: light with regard to the spherical mirrors. We can discuss some previous year question papers. Before looking into the questions, you must revise the relevant concepts in relation to the spherical mirrors. In the last class, we clearly go through some of the important formulas, especially how we can relate between the focal length and the radius of curvature. So we know f is equal to r by 2. Then the mirror equation, how we can relate between the focal length, object distance u, image distance v. We get the simple relation as 1 by u plus 1 by v equal to 1 by f. Then we find a relation for the magnification as m is equal to minus v by u. Then we represent the magnification in terms of object distance and f as m is equal to f division by f minus u. In terms of image distance, we derived as m is equal to f minus v by f. Look, the just happened the 2020 question paper. If you go through all the questions, you get the sufficient confidence to get into the board examination 2021. At first, we can go through the 2020 objective questions. See the speciality of this coaching. You can go through the first 20 questions so easily. The first one: when an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror, and this image is. So we know the concept. When the object lies in between the focus and the pole, we get virtual enlarged erect image behind the mirror, and hence the correct option is 4. Look, the next question. The laws of reflection hold true for the choices: the plane mirrors, only concave mirrors, convex mirrors, all reflecting surfaces. Look the figure. It is evident. It is applicable for every reflecting surfaces for normal conditions. Look the next question. Draw a red diagram in each of the following cases to show what happens after reflection to the incident ray when. The first question: it is parallel to the principal axis and falling on a convex mirror. On a convex mirror and the rays, so you just draw at first the normal. So it reflected with the same angle of incidence. If it retries, it must be the focus. So that is the answer for the first question. Look the second part. It is falling on a concave mirror while passing through its principal focus. So we know the simple concept: when a ray is coming parallel to the principal axis, after reflection, it must pass through the focus. But here, the rays are coming from the focus. After reflection, it must move parallel. The third concept, third question: it is coming oblique to the principal axis and falling on the pole of the convex mirror. It obeys the laws of reflection. Here we have to consider the principal axis as the normal. Again, one more question, the 5-mark question, 2020. Complete the following ray diagram. So here the object is given, the focus is given 30, and already the object location is in between the focus and the optic center, that pole, and hence the image should be on the behind. So we draw it again. So the focus is 30 centimeter. The object is placed in between the focus and the pole. 2 rays minimum needed to draw the image. So one ray is coming parallel to the principal after reflection passing through the focus, and the next one, it is with respect to the pole, reflected with the same angle but never converge. So supposed to be converged, and we can retrace it and we get a virtual erect enlarged image. Where? So we can use the mirror relation, and you can arrange them and you get the value for V is equal to UF by U minus F. And here the concave mirror F is minus 30. The object separation opposite to the incident light, and hence U equal to minus 15. So you can just substitute for U minus 15, F minus 30, and you get the answer V equal to 30 centimeter. So that is the just a completion of the ray diagram, first of all. What about the second part? The second part, find the nature, position and size of the image formed. In order to give the size of the image, so the very important concept is the magnification. So we know the minus V by U, here V is plus 30 and U is minus 15, you get the positive 2. So it is magnified, we can say enlarged, virtual, erect, at a distance of 30 centimeter on the back of the mirror. Third question, use mirror formula to determine the magnification. In the question here it is given only the data U and F. So we have to convert in that. We already studied in the last class. Look the equation. M is equal to F by F minus U. And here we have to substitute for F is equal to minus 30 and U equal to minus 15. You get the answer again 2. We already verified it through the normal relation. So students, you become so confident because of this previous year question papers. We are with the coaching from Darshana only 3 classes, but you gain more than 5 marks. So it is a good approach. So we're gonna go to 2018. What happened? Look the questions. An object of 4 centimeter in size is placed 25 centimeter in front of a concave mirror of focal length 15 centimeter. We have to give answer for 3. The first one, at what distance from the mirror should a screen be placed in order to obtain a sharp image? So we have to find the location, V. So it is given, it's a concave mirror. The object's location as minus 25, the focal length minus 15. Then you get the simple relation for V as UF by U minus F. You just substitution with the sign convention and you get the value minus 37.5 centimeter. The next part, find the size of the image. We know the simple concept, the magnification means height of the image by height of the object. But it is minus V by U. We know the concept values for V and U. We substituted it. We get the value minus. So you should know what is the meaning of minus. It is inverted. It should be real. So if we just take the magnitude hi by hy is 1.5, so the height of the image become 1.5 times 4, so 6 centimeter. The third part, draw a red diagram to show the formation of image in this case. And keep in mind, in every year there is a probability of 5 marks question for the board exam. Draw a red diagram to show the formation of image in this case. So the situations are so comfort for us. And already here it is the focal length 15, the object separation is 25. So we already got image distance as 37.5 centimeter. It is so comfort. But while drawing the curve, keep in mind you should give the arrow sign for the normal solid rays. Then only it can be called as a ray. And also you should give proper labeling. Look, the 2017, a good aspect. If the image formed by a mirror for all position of the object placed in front of it is always diminished, erect and virtual, then state the type of the mirror and also draw a red diagram to justify your answer. Write one use such mirrors are put to and why. So already we know at all positions the image should be diminished. So we can say the convex mirror, and keep in mind it is used as the rear view mirror of vehicles. It is one of the very important usage of convex mirror. Whatever may be the location of the object, it will give erect diminished image between the pole and the focus, but behind the mirror, and hence its field of view is maximum. That is a very important reason. Look, the middle question, we have to draw the ray diagram. So an object AB is placed, the minimum 2 rays are required to form an image. So one ray fall on the pole and it reflected with the same angle, and another one parallel to that one, but it move away from the focus. So retrace it, you get the virtual diminished small image on the back of the convex mirror. Then the B part, define the radius curvature of a spherical mirror. Find the natural and focal length of the spherical mirror whose radius curvature is plus 24 centimeter. We know the radius curvature means the separation between the center curvature and the pole of the mirror. We know the mirror makes formula as f is equal to r by t. Here the radius curvature is given as plus 24. So plus 24 by 2, you get the value 12 centimeter. Because of the positive sign, certainly we can say it is a convex mirror. Look, the next year, as a 2016, again we are waiting with the 5 marks question. It is desired to obtain an erect image of an object using a concave mirror of focal length of 12 centimeter. What should be the range of distances of an object placed in front of the mirror? So we can easily say we need an erect image. So that will be possible when we have to place the object in between the focus and the pole. So we can give the range as a 0 to 12 centimeter. And the second part, will the image be smaller or larger than the object? Draw a red diagram to show the formation of image in this case. You know the erect image is larger, enlarged one. And hence we can say, we can draw the figure so simply. We already done it. Again another question. The third one, Where will the image of this object be if it is placed 24 centimeter in front of the mirror? Draw the red diagram for this situation and you have to justify. So we know the simple concepts. Here the focal length is 12 centimeter, the object distance 24, so the U is double F. That means image should be double F. That is our concept, but we have to prove it. At first draw the red diagram. Look here. So we have to place the object at double F. The image should be at double F. We can draw it. But how we can prove it? You can use our mirror relation as 1 by U plus 1 by V is equal to 1 by F. So we get the relation for V is equal to UF by U minus F. You can just substitute with the sign convention. You get minus 24. So we can say the image at the same distance of separation, like object on the same side of the object. That is the answer. We can move through 2 to 3 again old question papers. For an object placed at a distance of 20 centimeter from the pole of a mirror, an image is formed 40 centimeter further away from the object on the same side. Then what is the nature of the mirror? Is the image formed real or virtual? You know the nature, it should be concave. Image formed is real or virtual? On the same side, and hence certainly we can say it is real. Draw a red diagram to show the image formed. So here the object lies in between the focus and the double F. Image should be beyond the double F. So that's drawn on it. And the last part, calculate the focal length of the mirror. You can use the simple relation. You have to substitute U, V and with the proper sign convention. So here U is minus 20 and V is minus 40. So you get the answer. So if you know thoroughly the theory, then you get the answer. Sure, no doubt at all. Look the another previous year question regarding the spherical mirror. The radius of curvature of a convex mirror used as the moving automobile is 2 meter. So from that data we find the focal length R by 2 as 1 meter. And here it is a convex mirror and hence it is taken as positive. A truck is coming behind it at a constant distance of 3.5 meter. So U is taken as minus 3.5 meter. Calculate the position. You can use the simple relation as 1 by U plus 1 by V is equal to 1 by F. That means V is equal to UF by U minus F. So proper substitution, you get the value as plus 0.78. So on the back of the mirror. And again the another one, what is the nature of the image? We can just find the magnification by the proper formula minus V by U. So you substitute, you get the value plus 0.22. Really it is virtual, but small compared to the object size. So we can say the virtual erect diminished image on the back of the mirror. See another question, a very good concept is varied. Find the position of an object which when placed in front of the concave mirror of focal length 20 centimeter produces a virtual image which is twice the size of the object. So the magnification is given, focal length is given, but we have to find the position of the object U. You can use the very good relation. M is equal to F by F minus U, but we need to find what is U. So crossing it, F minus U become F by M. Then we need to find what is U. So U equal to F minus F by M. So you have to just substitute what is the value for F and M with the proper sign convention. Here the virtual image is formed and hence we have to take M is equal to plus 2. And we substitute F is equal to minus 20 because of the concave mirror. You get the answer as minus 10. We can move with the last question. Again a very good concept. An object is kept in front of a concave mirror of focal length 15 centimeter. The image formed is 3 times the size of the object. Calculate 2 possible distances of the object from the mirror. So here are the 2 possible separations. So we know for a concave mirror, enlarged images may occur at 2 situations. One, if the location of the object is in between double F and F, you get a real enlarged image beyond double F. But if the object location is in between the focus and the pole, we get an enlarged image behind the mirror. So if you need a virtual, then you have to substitute as plus 3 for m. If it is a real, then you have to substitute as minus 3. So by using this concept as m is equal to f by f minus u with the proper sign convention. So if it is virtual, you get the value equal to minus 10. Already you know it should be less than our focal length. But if m is a minus value, the real one, you get u is equal to minus 20. It is greater than the focal length. So because of these questions, we get some confidence. You can to do the problem so easily. So try to solve maximum problems. In our Darshana material, a lot of MCQs are waiting, and it will really helpful to tackle very difficult problems so easily. So God bless you. Take care. Thank you.